Hello and welcome to this episode of The 12. Every month we interview an author of a book that we think you should be spending your time and money on to try and save you from wasting your time and money on another book. And this month we're going to be interviewing Davide Sivolella. How did I get it right?
Yeah, very good. That's correct.
It was good. Who is Italian, and he's written a book called Space Mining and Manufacturing. Now, I want to preface all of this by saying that I'm pretty gloomy about the next few decades of at least the economy and finance and investment. But this book is just incredibly optimistic. It really made me excited about the future. So if you're getting sick of me talking about doom and gloom all the time in my other editorial, this book is for you and this interview is for you. Davide, let's start with who you are and I suppose why you wrote this book.
Okay, yeah. First and foremost, thanks for having me on the show. It's really a pleasure. Who I am, I studied aerospace engineering many years ago, 20 years ago, more or less, because I love space exploration. After that, I started working in the aviation industry. I work and live in the United Kingdom in aviation, not in the space industry yet. But I always kept a very keen interest on the topic, and I wrote this book because out of an idea that I had since I was a teenager, essentially, because we know what space exploration is. We have seen since the late 50s satellites and people going into space, and mostly for scientific discovery, visiting planets, understanding our universe, or also for other reasons like national security, for instance. Communications, GPS, for instance, nowadays, so ubiquitous nowadays. But I always thought that there could be something else, more to it, that is not just having a few lucky people going into space and having fun and performing very fascinating experiments. And, studying a little bit how our solar system works, what's in it also, apart our planet. I kind of came to the conclusion that we could do also something else in space that is beyond just the simple scientific discovery. So this book that I wrote is sort of a manifesto, let's say. It's a way to provide a pragmatic and practical way to use space and not see space only as a destination to visit, to explore, but also as a resource to use for helping humankind here on Earth.
I think we should emphasize out of all of that one of the reasons there's been a bit of a pause in our ability to explore space and make use of space and achieve things in space is because it used to just be about science and exploration for the sake of it and as part of a propaganda war, effectively, during the Cold War. And after the Cold War, it was about emphasizing the lack of a Cold War. So all of these things were all about everything except making money and getting benefits for humankind or mankind out of space. And you argue that is what's about to change, where the next phase of space exploration and whatever it is we do in space is going to be almost like an industrial revolution.
Yes, it's definitely going to be a space industrial revolution, probably the fourth or the fifth revolution. And the reason is very simple. So what I argue in the book is that nowadays there is a lot of awareness about the damage that we are inflicting to our planet. There is a lot of talking about climate change, about zero emissions, about becoming carbon neutral, reducing our consumptions of resources, and many other ideas that are basically surrounding these main topics. And rightly so, because our planet that we know of is the only planet capable of sustaining human life in the universe that we know of, at least. Even if we find a habitable planet somewhere in a nearby star, these objects are so far away that it would take us thousands of years to get there. So even if we find Earth 2, it's impossible to reach at the moment. So we need to take care of the planet in one way or another. And there are many solutions, as we know. And one of the reasons why we are so damaging our environment is because we need resources for our society. We need to produce goods whatever things we have in life is the result of extraction of raw resources somewhere in the world, and then they have to be transported somewhere else where they can be elaborated, they be manipulated, they can be transformed in goods that we use for our daily consumption. And all of this as a cost, as an environmental cost, because we have obviously to damage the environment, the landscape, in order to get access to those resources. We need to elaborate them, and to do so, we need to use polluting chemical processes, for instance. Factories, they use a huge amount of energy, they produce a huge amount of waste that is released into the environment, and not always is possible to treat this waste in such a way that is then harmful for the environment. There is something fascinating. It's called the ecological footprint, which is basically kind of an index of how many resources of the planet we are using, and the capability of the planet to regenerate those resources, and also to absorb the waste that we are pouring into the environment. And associated to this ecological footprint index, there's also something called the Earth Overshoot Day, which is basically a day in a given year where we have, by that day, we have already consumed all the resources for that year that the planet could have given us for that year. So when I wrote the book in 2019, the Overshoot Day was the 29th of July. So this means that in 7 months, we had already used all the resources, all the capability the Earth could have given us in 2019. So this means that for the remaining 5 months, we had to borrow for the next year, essentially. And last year, 2020, despite the pandemic, Overshoot Day was only postponed by 3 weeks to the 22nd of August. So we still consume a lot of resources of the planet, which obviously has an impact on the environment that we need to preserve. And the problem of pollution, why do we have pollution? Is because we are damaging the biosphere. We are damaging this complex assembly of ecosystems that support life, and our life included. So one way to avoid this problem, because we still need resources, obviously, and we need to transform them into goods. So one solution could be to extract resources and use them and elaborate them in a place where we cannot harm the biosphere. And this is space, because Earth is part of the solar system. The solar system is formed by several celestial bodies. They were all formed billions of years ago from the same cloud of gas and dust that, thanks to gravity, they coalesced, forming planets, forming moons. And this means that resources that are here on Earth can be found also elsewhere in the solar system. So we can look, for instance, at the moon and the asteroids, which are the leftover from the formation of the solar system, because scientific discovery, thanks to space exploration, have shown that these bodies do have a lot of the resources that we also have here on the planet. So this is the point that I want to make. We have now the possibility to access new reserves of resources outside of the Earth. And in doing so, we are not damaging the environment, because that we know of, there is no life in space. There's nothing. So there's no danger of polluting the environment. So this is what I've been advocating in this book, especially because, as you were saying, now we are seeing a new revolution in technology. Getting access to space is becoming more and more, it's becoming easier and easier, and cheaper and cheaper. So in the past, it would cost something like $25,000 to send 1 kilogram of anything into space. Now, thanks to, for instance, SpaceX and their reusable rockets, they were able to lower this cost to $2,500, more or less. So this is one order of magnitude less, which is quite astonishing. It's really astonishing. If in the past it would take you to send into orbit $1 billion, now with SpaceX it would take you $100 million only. So it's 10 times less. And we are talking about considerable payloads like 10 to 15 tons worth of satellites into orbit, which is quite a considerable amount of mass. So because it's becoming cheaper and becoming also easier to get access to space, we now have the capability to start tinkering more with space. We can start developing hardware that can explore more in depth the moon and asteroids. We can have hardware that can, I'm referring to satellites and probes that can dig into the moon. We can extract resources from these places, and then we can elaborate them. What's going to happen is that because it's so easier and cheaper to get to space, that we will have the possibility to try a lot of technologies that are required in order to get access to these resources and to also exploit them. Because in the past, since access to space was so expensive, we couldn't launch so often. And every time you wanted to launch something, a satellite, a probe, whatever, a telescope, you had to be essentially perfect because you only had one chance to send into space your hardware. And so it would take a long time to develop a satellite because it had to be just a one-shot wonder, essentially. Absolutely, it had to work because, again, since it's so expensive sending satellites into space, if something breaks down, it's broken and it's left there. There's no a gas station or a breakdown recovery service because it's so expensive to send another recovery truck that can access the satellite and then repair it in situ. But now, because the access to space is becoming so much better, we have the possibility of saying we can develop different types of spacecraft that can probe the moon and the asteroids. So we can perform an extensive survey of their resources. We can develop several types of spacecraft for landing on these bodies and then start extracting their resources. And we can have different, we can try different techniques and methods in order to do that. We are still in a phase of research and development, essentially, where we are trying, we need to see what works and what doesn't work. But we can do it, especially because these technologies are not, they were already developed in the 60s, 70s, and 80s. A lot of these ideas were already put in papers, they were already extensively studied. So now it's just a matter of assembling together something and sending it into space for testing them and see in practice if they work or they don't work, or what requires or what needs to be improved, for instance. So we are a bit like at the beginning of the Industrial Revolution, like in the 1700s, when the first steam machines were being built. These engineers were basically tinkering with different type of materials, mechanisms. So we are now able to do that. And like with the first Industrial Revolution, those men were able to lay the foundation for what we have nowadays in terms of technology. So I believe that now we are ready to lay the foundation for then create a future similar to what we see in science fiction books and movies, where we have humankind, expanding into the solar system and actually using it for our benefit.
So you spoke a lot about what I expected to read in your book. What I didn't expect so much was the idea that we're actually going to be doing a lot of things in space with all of these resources. And there's a lot of things that we're going to be doing in space that we cannot do on Earth. And that this actually opens up a huge amount of benefits to humanity, which were not going to be possible unless we went to space. And I think you need to mention at this point as well, the misunderstanding that we're going to be bringing all of these resources back down to Earth, when actually we're going to be using them in space.
Yeah, no, that's a very good point, Scott. So space is an alien environment in the true meaning of the word. First and foremost, there is vacuum, which we don't have here on Earth. We have what we call weightlessness. So we are in a constant state of free fall, whereby the effect of gravity or gravitational attraction are basically masked. Gravity is still there; it doesn't disappear, but they're basically nullified. We also have the possibility to access an infinite amount of energy, which is the one coming from the sun, sunlight. And what this kind of environment allows us is to use processes that we cannot reproduce here on Earth unless we need to spend a huge amount of resources and energy. For instance, vacuum. A beautiful experiment that was carried out in the 90s with the Space Shuttle program, it flew 3 times, was the so-called wake shield facility. So essentially this was a disc-shaped spacecraft that was placed in orbit, and by moving forward, it kind of created a wake that enhanced the vacuum around itself. So you can think, because space is essentially a vacuum, but you still have free molecules and atoms roaming around, and there are ways in which you can further enhance this vacuum. You can get rid of these particles to create what they call a ultra vacuum. Ultra vacuum is used, for instance, for manufacturing microchips, the wafer or components for electronics, because they are so small, they are so delicate, they need to be built so precisely that if they were built within an atmosphere, then there would be contaminations, and obviously the product would be not as good as they are now. So in space, this experiment, this spacecraft, the Wake Shield facility, was basically built in order to experiment with a process called molecular beam epitaxy, which basically consists in shining a beam of atoms or molecules into a substrate in order to build up layers. So microchips are basically, it's kind of 3D printing, because you need to build up layers upon layers within a certain sequence. Then you have other processes where you have to remove material, then you add, it's quite complex. And with this process, you can lay out these layers, and it does require ultra vacuum. So in this experiment, they actually managed to produce high-grade quality microchips in space. And the idea was to actually then scale up these activities to have a fully fledged factory in space in order to produce microchips. Then, unfortunately, it didn't go through because, again, access to space with the space shuttle was infrequent, was very expensive. And so the project, unfortunately, died there. This is just show you how you can use space in order to exploit a property that here on Earth is very difficult to attain. Because if here on Earth we have the atmosphere, so if you want to manufacture electronic components, you need to pump out the atmosphere. So you need to have energy. You need to do it constantly, because otherwise the atmosphere will try to come back inside your manufacturing chamber. But in space, you already have a vacuum. So you're already there. If you want, you can push a little bit more that vacuum. You can create a little bit, you can improve on that vacuum, but it is much less effort. And the vacuum of space is always there. You don't need to do anything. Or also, because there is the effect of gravity are not felt on objects, then you can start manipulate fluids in very interesting ways. Because you don't have phenomena like sedimentation or buoyancy. So if you're mixing together, you can mix together fluids that normally would not mix together, like oil and water, for instance. So you could create alloys of metals that here on Earth would never mix because the chemistry would not allow it. But unless you apply a lot of energy in order to do that, a lot of heat, for instance. But in space, at room temperature, essentially, you can have these fluids or different materials mixing together. You can create super alloys that have special properties, maybe being as light as balsa wood, but as strong as titanium, for instance. And you can do this because you are exploiting a property that space gives you for free, essentially, which is the absence of gravity. I call it absence of gravity, but what I mean is that gravity is not felt. Okay, this is something that we cannot do here on Earth. And other processes might require a certain amount of radiation, for instance. Where in space we have a lot of radiation. Our star emits, a huge amount of radiation. We can harness that kind of radiation. You can design apparatus that can regulate, they can modulate the amount of radiation that is a certain surface is exposed to, and on the surface you can have a process taking place. Or what else? Because you have access to an infinite amount of sunlight, you can concentrate that light, for instance, and you can use it for melting metals, for instance. So you can have a furnace, essentially, where you can melt your raw metal, and then with that fluid, you can move on to other part of the process for building up your whatever you want to build up. There was a very interesting study that I reviewed for the book done by General Electric in '85, where they designed essentially a microchip facility. It was fairly small, not particularly big. It could have been assembled with 2 or 3 flights of the space shuttle. And basically, they designed a whole system where by using vacuum and robotic manipulators, they could build up wafers for microchips, for instance. And the process was really neatly laid out. Unfortunately, it only stayed on paper, but it really showed how, by clever usage of the property of space, you can actually reproduce what we do here on Earth. And you can do it not necessarily better, but you can do it without polluting the environment, for instance, without using energy or resources that come from Earth.
There were some comments about Elon Musk bringing back to Earth so much gold that gold would be completely worthless. And I think I really want to address this because of the nature of the misconception, but really the argument is that we can do such wonderful things with the resources in space.
That's right.
That the final good comes down to Earth. Can you speak about that to try and make clear that this isn't about bringing back several quadrillion dollars worth of metal to the surface of the Earth and then trying to refine it?
That's right, yeah. Because otherwise it would defeat the purpose. Because we just said that our industrial manufacturing activities is one of the culprits for pollution, for damaging the environment. So if we extract resources in space, we're already one step ahead in not damaging the environment. And then because we can exploit the property of space, we can actually build factories in space that can take these resources and then they can be transformed in products that we need. And then we can deliver them back where we need them on Earth. And in this way, we have removed 2 of the main or most important ways in which we are damaging the environment. So, yeah, as you said, is not about bringing trillions and quadrillions, whatever, tons of metal and gold or platinum back here on the planet. What we want to do is to get the resources in space and then use them in space and then bring the final products here on Earth. That is what we should be doing. And I didn't say before, but the resources that we have available are really huge. We have, on the moon, we have iron, titanium, aluminium, magnesium, silica. On the asteroid, it's the same thing. So there is, also platinum, for instance, which is platinum group metals, which are extensively used for electronic or technological applications. Rare earth materials, again, same type of applications, and they are all available. So there is no really shortage. We need to get them. It is not obviously extremely easy to get them, but it's not more difficult than accessing resources like we do here on Earth, because digging mines in forgotten places on the planet is quite demanding anyway. We are doing it because we don't have any choice, right? So we do have the capability to access remote places here on Earth with sophisticated equipment, even automated equipment, using artificial intelligence or a high degree of intelligence. Already there are mining companies that are they're making their mines automated, basically. There are robots that are digging and then bringing raw materials to the processing plant, and the processing plant is almost fully automated, so there's a little human supervision. So this is not something that we haven't done. We are doing it already. So it's not beyond our possibilities to access the moon or asteroids in order to access the resources.
What was the big preventing factor then that has stopped us thinking about these things since they were first considered in the 60s and the 70s?
Yeah, so as we said at the beginning, the space age started for the wrong reasons. It started because of this war between ideologies, the capitalistic ideology and the communist ideology, and the United States and Soviet Union try to outdo each other at every possible turn. So space became the new battleground. That's why Kennedy, the Russians were the first one to send a man in space. So Kennedy said, okay, so we need the next best thing to do is to be the first one on the moon. So that's how the space race was started. It was only a showing off. There was not a clear vision from a political standpoint, because engineers and NASA and also other institutions, and I believe also in Russia must have been the same, they had their mind placed on a more paced space development. They had in mind to go build space stations, then going to the moon, using resources in order to produce goods and so on. So they already were thinking along those lines, but the necessity of the Cold War, unfortunately, trumped everything else. So we started for the wrong reasons. Then we continue also for the wrong reasons, because as you said, after the Cold War, we tried to prove that that we were all friends. So like the International Space Station, for instance, is a beautiful piece of technology, but it was also a way for the United States to keep close to them a lot of Russian engineers that all of a sudden, after the fall of the Soviet Union, found themselves without a proper job, a secure job. So rather than seeing them going maybe to a non-allied country and providing the services for developing missiles, for instance, they decided to include Russia as well in this program of the space station. So again, that was more of a geopolitical effort again. And then, as we said before, there is also this problem that going to space was always an expensive proposition, because rockets were designed until SpaceX to be non-reusable. The space shuttle was an exception, but it didn't work as well. Going to space has always been very expensive because rockets are one way. You just use them once and you throw them away. And that raises the cost, obviously. If you can reuse your vehicle, obviously the costs are spread over a longer period of time or on different missions. So when SpaceX arrived, they really revolutionized, they completely changed this way of thinking. Because it was, as they've shown, it was not impossible, technologically speaking, to do it. You just needed somebody willing to do it. And they were willing to do it. It was a big gamble, and it worked. So now, also other companies, the historic companies that were developing rockets before, now they're saying, well, we need to follow through. We need to, put ourselves also into this game. Otherwise, we will be left behind. So you will see that in the next few years, we will have, already now, there are companies, small and big and medium, that are developing their rockets. They are developing them in order to be easy to use, in order to give you even weekly access to space. Some of them are thinking about reusable rockets, like Rocket Lab, for instance, ULA, United Launch Alliance, in the United States, SpaceX, Blue Origin, funded by Jeff Bezos. So altogether, these companies have allowed us and will allow us to access to space in a much easier way and cheaper way. So the point I want to make is, because obviously we don't have yet a mining industry into space, because there is a lot of work to do. We need to we need to develop spacecraft that are specialized in mining the moon or mining a particular type of asteroid. Asteroids have each asteroid is a world on its own, because it has different composition, different type of consistency as well. So you need to develop a large range of spacecraft in order to access those resources, because also we need to try what works and what it doesn't. So because there's so much work to do in terms of experimentation, this means that we need to send into space also a large amount of spacecraft. In the past, because access was so restricted, you can only do so much. So that's why you would have a probe sent to one asteroid every, 5 years, because there were no resources enough in order to do more. And remember that for every mission that is approved, there are tens of other missions that are discarded that will be equally good. So now we have the possibility to basically try what we want to do, because access is easy. So this is really the enabler of this revolution. We access, we can try, we can follow the SpaceX model, which is try, fail, see what has worked, what hasn't worked, then feedback in order to improve, and then try again until when it works. And this process in the past would have been very expensive, impossible, in fact. But now, as I said, I keep repeating, but that is the key. Because space is so easy to access and so cheap, we can try more things. And that will give us more experience, will give us more data that we can then use in order to scale to mass production technology that works, and then jumpstart the mining industry in space and manufacturing also.
There's a few economists who I like to read who claim that the greatest invention in humanity is the shipping container. And this reusable rocket idea strikes me as very similar. It's the idea that once you make it possible to do things, then those things start to follow on. I think we've given a really good rounded view of what's happening in the book and what it's about. Let's dig into a few specifics. We've mentioned some on manufacturing, like microchips, and the idea of balsa weight but steel strength material. But let's dig into the mining side with a little bit more, the same sort of depth as you've mentioned for the manufacturing. And I think we should start by comparing how mining on the moon and on asteroids is very different to Earth, because Earth has these tectonic plates moving around, and that's what makes resources concentrate and accessible. But that doesn't happen on the moon and on asteroids.
Yeah. So basically, Earth is a big planet. So as such, it has a significant gravity, amount of gravity. And as you said, during the formation of Earth, when Earth was in a molten state, the heavier elements, because of gravity, sunk towards the center, while the lightest basically arose to the surface. So that's why the core of Earth is mainly made of iron, for instance, or radioactive material like uranium and thorium, for instance, while the crust is made of silica, which is a much lighter element. Then, as you said, because of the tectonic movements, geology, the presence of water, of an atmosphere, so oxygen in particular, we have the fortune to have resources concentrated in certain areas, specifically concentrated in specific areas that allow us basically to direct our effort, mining effort, in those areas rather than just going and plowing the whole surface. The moon is a much smaller body, so there has been some stratification, like happened here on Earth, but much less. So this means that resources are spread around. I don't say they're homogeneously spread around, but you won't find a specific concentration of iron or nickel in a specific area of the moon. You might, in very specific cases, if maybe in that area was subject to an asteroid impact, and maybe that asteroid had a specific composition, so you might have a slightly higher concentration of that resource that you're looking for. But otherwise, and the same goes for asteroids, these resources are kind of spread around. So this is not necessarily a bad thing, because you can think of a mining equipment that can extract several of these resources. So you can have, you are digging out, you can dig a trench on the surface of the moon, for instance, and all that soil, it's called regolith, okay? The soil that you see on the surface. So this regolith is taken, and then with mechanical processes, with electrochemical processes, you can separate the different constituents. So you can separate iron from nickel, from titanium, from silica. You can extract oxygen. You can extract water also if you are at the poles, for instance. So as you go along, as you are extending your mining activity, you are basically able to access different resources. And as I said, it might not be a bad thing necessarily, because here on Earth, if what happens is that you need to mine different resources, then those resources, they need to be transported to a central place, a factory, for instance, where they need to be then put together in order to manufacture what the factory is producing. On the moon, you can think of a mining and manufacturing system that are combined together, because all the resources are basically in the area, so they're already available, and so you can use them straight away for producing whatever you want to produce. You can think of traveling, mining, and factory assembly, for instance, for this reason, which might be even a good idea from an energetic point of view, because you're not wasting that much energy in having to, ship resources from one place of the moon to another, but everything is together. And for asteroids, it's the same thing. And asteroids, the good thing about asteroids is that they are essentially small. They're very small. They can range from, few meters in diameter to hundreds of kilometers. But if even we consider just those that are 10 meters in diameter, there's a very interesting proposal where basically is based on a process called optical mining, which is a high-tech version of, I'm sure everyone when he's a kid has used a magnifying lens to concentrate sunlight on a piece of paper to start a fire. So this is basically an high-tech version of this process, because this spacecraft developed by a company called TransAstra, they're based in California, it's based off two mirrors that actually first you get to the asteroid. Then the asteroid is enclosed into a flexible bag, so because you don't want the material to escape. And then there are two mirrors that concentrate sunlight, and they create a beam of light that impinges onto the surface of the asteroid. And by heating up the surface to 1,000, 1,200 degrees Celsius, you are creating basically, the rock tries to expand, right? But the surrounding rock, cold rock, constrains that expansion. However, because the rock is so hot, it wants to expand, it will eventually break. It will fracture, exposing new material ready for being fractured. So you can use this system basically to fragmentate, to crumble a small asteroid like that. And then in the process, if there are volatiles, such as oxygen, for instance, that can be collected into a separate tank, for instance. It can be liquefied or solidified. And what is left, it remains in the bag containing the asteroid. And this material can then be, for instance, sent to a processing facility that allows to further fragmentation to kind of a powder. And then you can use like there's a chemical process called the MOND process, where you use gaseous carbon monoxide that is able to bind to the metal oxide into the rock, and you extract it. It creates a gaseous compound called carbonyl, and this gaseous compound can then be liquefied, and then with a process of fractional distillation, which is also used by the petrochemical industry, you can then separate the carbon from the pure metal. So this process allows at the end to have your metal ready for use. And the interesting thing is that this company has received funding for now sending a small prototype into orbit in probably 2 years' time. So they did a lot of the theoretical work. They tested it on Earth. So this way of optically mining rocks has proven to be effective, to work. And now they're developing a prototype to try it also in space. And that is very exciting, because this is what we really need to do now. As I said before, there are many ideas, and now it's time to try them for real in space.
For those of you who are interested in rare earths and the stranglehold that China has, this is a big opportunity. And that's one of the reasons I think it's going to have to be pursued by a lot of governments, or at least supported by a lot of governments. But let's leave that to the side. Yeah. I think...
in fact, if I may add something, China is very interested in resource mining.
As well. That's right. They don't like some of the strangleholds that other nations have. The thing that I found interesting in your book about all of this is that doing the mining and the beneficiation and everything that we do on Earth, we can't use the same techniques. And so we've got to figure out which techniques will actually work in zero G, in a vacuum, and so on and so forth, such as trying to recreate those same conditions, or using the conditions in space, such as sunlight, to our advantage. So nothing is as simple as it sounds. And the fact that we can do all of this stuff on Earth doesn't tell you that we're going to be able to do it in space. So there's a huge amount of uncertainty still as to which companies and which technologies will make the most of this. We we'll be doing a part 2 of this interview where we dig into some of the ideas and technologies that we think are leading. But for now, it's worth noting that there's lots of uncertainty for now about who will be successful. Let's turn to the idea of the moon. It seems to be turning to glass. I was really surprised to learn about this. Every time there's a meteorite impact, it turns more of the moon's surface into a glass-like substance. And it seems to me that the moon's covered in glass. So tell us about that.
Yeah, I wouldn't say it's glass like window glass, because typically when we talk about glass, we are referring to a compound that does not have a crystalline structure. So you can arrange the atoms in a tidy configuration, for instance, that is a crystalline structure, and that has specific properties. Otherwise, for several reasons, the atoms can be instead arranged in a amorphous way. So there's no particular order in which the atoms are arranged together. And that is what we call a glass. But the moon, what's happening on the moon, every time there is an impact. Now that obviously there are less impact. At the millions, billions of years ago, the solar system was a much busier place with asteroids flying around. And so impacts on the moon and on Earth were more frequent. So every time there is an impact, all that kinetic energy is abruptly impressed into the surface, and the surface is heated up to thousands of degrees. So this temperature is enough to melt the materials of the surface. And because you are in space, where you are in a vacuum, and depending where you are, you might be in the shadow where there are, I don't know, you might be close to zero absolute, minus 300 degrees, almost. This molten material won't stay in that liquid state for very long. Actually, in a matter of seconds, it will solidify. And since it doesn't have time to arrange itself in an ordered structure, the atoms will just arrange as it comes in a random way. And that is the glass that you are referring to, this glass state. But again, it won't be much of a problem, because as we said, and we need to do the same here on Earth. It's essential for the process of mineral extraction that you have to pulverize your rocks. They need to be really reduced to a fine powder. You cannot use a big chunk of rock straight away, because the process of extraction, since we are using chemical reagents or electric field, magnetic field, they wouldn't work effectively. So you want to increase the exposed surface, and in order to do that, you need to pulverize the rock. So on the moon, on the asteroid, it will be again the same thing to do in one way or another. Maybe with drums, for instance, which how we do it here on Earth, that are basically by turning, being inside. They have special veins or rollers that are at every turn crunching the rock until when it's ready for the next process in chemical extraction of the resource. So the technology that we have here on Earth might not work exactly at face value in space. They might need to be adapted a little bit, but it won't be something completely different. We can still use knowledge that we have accumulated in thousands of years of extracting minerals from the Earth. And something also is interesting to consider is, let's say that, for instance, there's one process for extraction of minerals that is called fractional distillation, which is the same process used for by the petrochemical industry for basically extracting the different products from crude oil. So you have these tall towers where you have liquid oil at high temperature that is boiling off, and the configuration is fairly complex, but it allows basically to liquefy different components of oil, and it works well under vacuum. So on the moon, asteroid in space, we have vacuum, but it works particularly well. Actually, it only works if there is gravity. So what we could do in space is to create gravity, because we said gravity, there is the absence of gravity, is weightlessness, but we can artificially reproduce or simulate gravity by, for instance, turning, you have kind of, I'm sure you've seen it in sci-fi movies, kind of a big wheel-shaped station that rotates, and by rotate, the centrifugal force that you feel at the walls, it will give you the impression that there is a gravitational field. And so in this way, you are reproducing the effect of gravity, and this process could be used as well in space. So this is something else important to consider, is that if we want to use a process that we know works well on Earth, but requires gravity, or a certain amount of gravity, not necessarily 1G, which is the amount of gravity that we feel here on Earth. It might be only a fraction of it. Then we can build a space station that have the capability of rotating. It is not particularly difficult to do. By rotating, they can simulate a gravitational field, and then we can use those processes as well.
You mentioned about the moon being hit by meteorites. It's not just the moon that might get hit, it's also Earth. One of the arguments behind all of this is that we don't actually have a choice about any of it. The sun is changing over time, and at some point, Earth will become inhospitable to humans. So we do have to figure out a way of getting off here long before. We can argue about pollution all day long, but at some point we're going to have to do this.
Yeah.
Earth is going to get into trouble. One of the possible ways is, of course, an asteroid striking Earth. And so I'd love to talk about Apophis, which is approaching us and will again approach us in about, is it a decade's time? And I suggested to you in an email that we might actually catch Apophis.
Yeah. I'm not sure if Apophis could be caught per se, but Apophis is an interesting asteroid because it belongs to a category called near-Earth asteroids. So this is something I should have clarified before. Typically, asteroids are located in a region of space between Mars and Jupiter, in what they call the asteroid belt. However, because Jupiter is such a large planet, it has an influence on these asteroids. And if for certain asteroids that have specific orbital parameters, for orbital parameters I refer to distance from the sun, then Jupiter over time can nudge them out of their place and push them closer to the sun. So some of these asteroids will fall into the sun, so we'll get lost there. But others will basically enter into a new orbit around the sun that is also very close to Earth. So Earth takes 1 year to orbit the sun. These asteroids, their orbits are more or less 1 year as well, maybe a little bit less or a little bit more. And some of them, they also cross the same orbit than Earth. So because of mechanical celestial mechanics, it might happen that one day, one of these asteroids, like in the case of Apophis, it might pass very close to Earth because, by moving around, it will happen that there will be a moment in time where Earth and the asteroids are fairly close to each other. And hopefully the asteroid, when it crosses Earth orbit, won't do it when Earth is in that point, because this is when you have an impact. So near-Earth asteroids are very interesting because they are very accessible. It is easier to get to them, because if you want to go to the asteroid belt, it will take you probably 1-2 years, maybe even more. It depends where you want to go. But near-Earth asteroids, because they can come close to Earth, it's easier to access them. It might take maybe only a few months to get there, which shorten the trip to get there. Unfortunately, space travel is not like seen in sci-fi movies where you can move from one place to another with a blink of an eye. It requires a lot of time. So if you can shorten the time, it's welcome. And in the cases of the idea of catching Apophis, a few years ago during the Obama administration, there was the idea of reaching an asteroid. So the goal was not to go back on the moon because we had already been on the moon, but it was to do the next best thing, to set foot on another celestial body. But as we said, going to an asteroid, it still requires some time. And all those months of traveling with astronauts, doing nothing, exposed to radiation, is not very, very healthy. So NASA developed the idea of catching a small asteroid and then bringing it near the moon, placing it in a very stable orbit that would never allow the asteroid to come down and crash on Earth, and then have astronauts reaching the asteroid. Obviously, the moon is only 2 days away, more or less, in terms of space travel. So it would have been quite an interesting mission to accomplish, and very helpful for what I'm advocating in this book, because we said that we need to access asteroids in order to extract their resources. So what you can do, you can go directly near the asteroids, or you can bring the asteroids also close to you, so you can have maybe better chances to exploit that asteroid. You might think about having a whole space station built around the asteroid, for instance, and then little by little trying to eat away the asteroid using the resources, and having also your manufacturing plant just in the same place. So this mission, it was called the Asteroid Redirect Mission, would have really given us a lot of experience in terms of catching an asteroid and also changing its position, not only for the purpose of space mining and manufacturing, but also because, as you said, the possibility of an asteroid striking Earth is not impossible. In fact, frequently there are asteroids entering Earth. Just a few last week here in south of England, one asteroid re-entered, and it was seen. It was actually so luminous that it's considered a fireball. So it was really like a small explosion in the atmosphere. And when it exploded, the shock wave was felt apparently across all the south of England, even up to Wales. So it was quite a large region. And clearly the asteroid didn't fall on anybody. Probably it just fragmented, and fragments might have just, peppered the ground underneath, but nobody got hurt. A few years ago in Russia, in Chelyabinsk, a large asteroid re-entered, and that was really impressive. So impressive that when it exploded, the shock wave caused damage for millions of dollars in that city of Chelyabinsk. Luckily, nobody got hurt again. And another fantastic event happened in 1908 in Russia again, Eastern Russia, Siberia, Tunguska. And that apparently was something like the estimates vary between a 90 to 180 meter diameter asteroid that exploded over this region, Tunguska, and it basically flattened 2,000 square meters of trees. So the whole forest completely knocked down. If an asteroid like that had fallen over London or Tokyo, can you imagine? The pandemic that we have now would have been nothing in comparison to the damages, to the toll on human life that an asteroid impact like that would have caused. So also learning how to redirect an asteroid is also good for planetary protection, because we might want one day to be able to maybe nudge an asteroid a little bit out of, a possible course of intersection with Earth. But I think it's a little bit far away, to be honest. I don't believe we are in danger yet of having a catastrophic event like that yet. But again, it's good to be ready just in case.
I wanted to start a bit of a tradition for this show, the 12, of overstating the claim of the book, the central claim of the book, of the author that I'm interviewing, and then having them react to it. I find it an interesting way to see whether I really captured the idea of the book. So let me try and sum up your book and see what you think. And again, I'm overstating it. I'm exaggerating it to try and get to the kernel of it. And I think what you're saying is that mining and manufacturing in space is going to solve all of the world's problems much sooner than anyone expects. Is that fair?
Good one. I'm glad you asked, because I love space. What you will call a space advocate. But at the same time, I'm also a pragmatic and practical person. So a lot of space advocacy groups and individuals, as you said, they hail space as the solution. Let's go in space, let's build colonies in space, let's go to Mars, and that will solve our problem. I don't believe this is the case, because the problem of climate change, pollution, social instabilities, and anything that derives from these problems is sufficiently complex and multifaceted that does require many different solutions. That is obvious. What I want to say on the book, and I also highlighted a few times, is that this is not a panacea. This is not the solution. It's a solution. It's one possible solution that should be entered into the mix of ideas that we are bringing to the table for helping our planet to survive. So every idea, I believe, is welcome. We want to reduce emissions. We want to recycle. There's a lot of talking about circular economy, reducing wastage, trying to use different resources for doing what we are doing now, be more efficient. All is very good, and we should be doing it. But because, as I said, it's no longer science fiction thinking that we can go in space and mine resources over there. It's something that we should be attempting doing it. It would be really a waste not doing it, because the potential benefits the rewards are considerable. So I don't have a crystal ball. I don't know if I cannot say with 100% certainty that it will work, but there is a potential to explore, and we can explore it now. We have the means to do it. So the reason why we try to save the planet is because we are saving it more than for ourselves, for the future generation, right? For our children and their children and grandchildren. So we ought to try every possible solution. And space, you see space as a resource should be one of them. It can also be very profitable anyway, because before, let's say, I think the point of demarcation is something like 2003, essentially. 2003, in February, we had the second space shuttle disaster. And that basically made the Bush administration of the time to say, okay, the space shuttle program will be canceled. Okay, and they canceled, and it continued for a few more years until 2011. The next administration, Obama administration, started the idea of commercial space. So of having NASA relying not only on itself to develop hardware, but also on private companies, so private enterprises, because clearly they are much better managing resources. They can do. NASA is a wonderful institution. They've done wonderful things. A few weeks ago, a new rover landing on Mars. But when it comes to develop something that is affordable and cheap, easy to use for frequency, they cannot do it. But a private company like SpaceX has done it. But they finance SpaceX even when they had not launched yet a rocket. Actually, they were failing with their first Falcon 1 rocket. But they trusted them, and that was a good gamble because it gave SpaceX the capability to further develop and then work their plans to build up a reusable launcher. So after that point, we're seeing more and more companies. In fact, to be honest, I should write a second edition for this book now because since I published it only 2 years ago, small and medium companies have come up with and been contracted by NASA to develop, okay, maybe just small, nothing as large as a rover like the Perseverance rovers, but they've been contracted to study and develop technologies that will be sent into space and then tested over there. And these are technologies that we will need for space mining. There are several companies working and being contracted by NASA to develop ways to mine ice on the moon because water can be used as a propellant for rockets. And that would enable us also to, let's say, have propellant depots in space that you can refuel your spacecraft and send them away, maybe to another asteroid for more exploration. They're developing companies that are interested in mining. Their business is to understand how to mine the moon, for instance. So they're developing rovers or sort of mechanical apparatus that can, dig regolith and then bake it and try to extract materials. Some of them, one in particular called Astroscale, will be sending a small rover in a few years' time. You have also companies that are interested in manufacturing in space, so in trying to understand how to use, for instance, 3D printing. 3D printing is a huge industry here on Earth. It's a wonderful process, and it's been now already now tested on the International Space Station. So, because more and more companies are coming into the mix, clearly there is they wouldn't do it if it was not profitable. Right? They are receiving funding, so there are people that are believing in what they are doing, and okay, maybe they might not be profitable at the moment yet, but the potential is there, and investors are seeing that there is potential. So that's why they are constantly putting money into it. There's another company called Axiom Space, and they have got a contract from NASA to build the first commercial space station. So they already start cutting metal for building the first module of this small station. By 2024, they will send this module to the space station, and they plan to basically rent this module to whoever is interested in doing research in space. NASA is also trying to commercialize this space station, but it's a bit more difficult to do that. But this shows that there is potential for many more activities happening in space. And so that's why I'm saying it won't be the solution, but it can be a solution. It can definitely be a solution.
I want to close by saying something that I've written often, but I think it's particularly relevant to this story. And it's the idea that we didn't run out of stone in the Stone Age, or bronze in the Bronze Age, or iron in the Iron Age, or gold in the Golden Age, or Scottish people during the Enlightenment, or steam during the Industrial Revolution, or you're not going to run out of uranium. And if you can figure out what the next big revolution is, that's a huge generation of wealth and investment profits, which is what our readers are interested in. And I think it's going to be space. And I think you've given us an excellent introduction to that. So, Davide, thank you very much for joining us.
Thank you for having me.